look at some example problems with coded data so you can apply those formulae. So here, time taken, T hours, to deliver letters on a particular route. Each day is measured on 250 working days. The mean time taken is 2.8 hours. Given that sum of t minus 2.5 squared equals 96.1, find the standard deviation of the times taken. Okay, so we know that sum of x over n is equal to 2.8. And so we know that the sum of x over n is also going to equal sum of x minus 2.5. We're going to use the same coding, that's very important, over n plus 2.5. So our coded one is going to be a coded mean, which is equal to x minus 2. I should say t over n is equal to 0.3. And just, it's not essential, but just so you know, if you wanted to find sum of 2.5, you'd get 0.3 multiplied by 250. But we don't need to know that. So now we have our coded mean. Great, now we can already find out our standard deviation. And we can use the fact that it doesn't matter if you subtract a constant, the variance and standard deviation will stay the same. We should probably write a full formula first, then write our substitution. Point 1 over 250 minus 0.3 squared is equal to 0.543 to 3SF. And then this next question, the heights x centimetres of 200 boys and the heights y centimetres of 300 girls are summarised by the following totals. Sum of x minus 160 squared equals 18,240, sum of x minus 160 equals 1,820, sum of y minus 150 squared equals 20,100, and the sum of y minus 150 equals 2,250. So we need to find the mean. And the quickest way to find the mean is just to make sure all the coding is the same. So say this is sum of x minus 160. If we were to add 10 times 200, that will give us sum of x minus 150. Because there are 200 boys, what this means is combined heights of all 200 boys minus 160 for each boy. So that means minus 160 times 200. And if we want to match the y minus 150, we just need to add back 10 times 200 to get sum of x minus 150. So then we'll compute this, sum of x minus 150, that is equal to 1820 plus 2000, which is equal to 3,820. So now for our mean, we can add these two. Divide it by the total number, which is going to be 500, which is 200 plus 300. And then we're going to have to add 150. This will be equal to root 20 plus 2250 divided by 500, 150. That's going to be equal to 162.14 cm. And now we need to calculate the variance. So I will move this down here and we can look at variance. Okay, we need to find sum of x squared and sum of y squared. Now, sum of x minus 160 squared plus 160 squared times n does not equal sum of x squared. Because remember, this is, it's a square, so you're going to get x squared minus 320x plus 160 squared, and that's going to be done for every single height, which is different. It's not going to be consistent, so you cannot do that. Instead, you have to use the fact that the coded variance when you subtract a constant from everything or add a constant is the same. So, sum of x squared over n minus x over n squared is equal to sum of x minus 160 squared over n minus sum of x minus 160 over n squared. So just substitute in what you know. X squared over n. Remember, sum of x, we can figure that one out. It's going to be 1820 plus 160 times 200. And our n is 200. That's equal to 1240 over 200 minus 1820 over 200 squared. On the right hand side we have 8.39, and on the left hand side we have this on the left hand side. So then we rearrange this. And then finally multiply both sides by 200. And then we do pretty much the same thing for y squared. Sum of y squared over n minus sum of y over n squared is equal to sum of y minus 150 squared over n minus sum of y minus 150 over n squared. So once again, write in everything you know. And the sum of y is going to be 2250 plus 150 times 300. $20,100 over n, which is 300 minus 2250 over 300 squared. So on the right hand side we have 10.75. I'll just skip straight to the rearranging. This is that if you didn't cotton on. 17. So sum of y squared is going to equal 7,445,100. So now we'll find our variance again. It's going to be sum of y squared plus sum of x squared divided by 500 minus, well, our mean, which we already have, just down here, minus, well, we'll write it out in a formula first. So our x squared is 5,720,640, yep, plus our y squared minus our mean squared, so that gives us 42.1 to 3SF, and this is going to be in centimetres squared because they're given in centimetres, and variance, because we're squaring, will give units of centimetres squared, and this is to 3SF. So that's pretty much it for coded data. Just remember, when you code a mean, you need to add back the constant that you subtracted from every value in the first place. And for the variance, when you subtract the same number from every data point, variance and standard deviation will not change. And remember, like here, what we're doing with these combined sets of data, you have to remember to find those totals of x squared and y squared, or sum of x and sum of y first before evaluating a mean or a variance. You cannot just average the two, it doesn't work. And other than that, these codings also work for grouped data. You just have to multiply by the frequency. I'll tell you the formulas. Sum of x minus b f over n plus, sum of f equals the sum of xf over sum of f, and sum of x minus b squared f over sum of f minus sum of x minus b f over sum of f squared is equal to sum of x squared f over sum of f minus sum of xf over sum of f squared. Do lots of practice